Hi everybody, this is section 4.2 for our Math 211 course and our geometry from our geometry textbook. And in 4.2 we're going to talk about congruent figures. So we're going to identify corresponding parts in congruent figures, and we're also going to prove triangles congruent. All right, just a reminder that congruent figures have the exact same shape and size, and all the figures below are congruent. You could flip, rotate, turn them. Doesn't affect whether they're congruent or not. The orientation of them doesn't affect whether they're congruent or not. They are the exact same size and the exact same shape. The orientation of the figure does not matter. Okay, when you have congruent figures, you're always going to look for, they're going to talk about corresponding sides and corresponding angles. So corresponding sides are always going to be the sides, that have the same measure. So here, for instance, if we look, side AB corresponds to side RS. And I know this because in the picture, they're all both marked with 3 slash marks. I also know that AC will correspond to RT. And again, there's the 2 slash marks, and then our final corresponding side will be side BC and TS. Angles that match up are going to be angle A and angle R, because they both have 3 arc marks. Then we have angle S with angle B, because they have 2 arc marks. And then angle T corresponds to angle C. So those are the angle measures that have the same measures. Okay, here they want us to name the congruent parts in the 2 quadrilaterals because it's a 4-sided figure. Now, sometimes they did color code the sides here, so it makes it easier to see. However, sometimes they don't do that and they're not oriented the same way, and it might be hard to tell. But if they name the 2 figures for you, when you're naming congruent figures, one thing that you always have to make sure you do correctly is you have to keep the order of the vertices in the same order. So A, B, C, D, we can tell because this has TR, QS has to be in the same order, that I can tell that angle A here corresponds to angle T. So those are angles that are congruent. So angle A is congruent to angle T. I also know that angle B is congruent to angle R. And if you look, you have a blue and I think it's purple side, and then a blue and a purple side there. So you can kind of see it on the picture too. So angle B is congruent to angle R. Then we also have angle C, which is right here, is congruent to angle Q. And then our last pair would be angle D is congruent to angle S. Now sides, this is nice too because it helps it make it a little bit easier to figure out your sides as well. AB, which we can see on here is blue, corresponds to TR, which is also blue there. So we can put AB is congruent to TR. And it's nice when they name it because it helps keeps the order of the segments in the right order too. Next, I'm going to go with BC and RQ. So I'm going to say BC is congruent to RQ. And then we have CD is congruent to QS. And our last one is going to be AD is congruent to TS. Okay, so here we have a picture of an origami cat, and they want us to, given that triangle ABC is congruent to triangle AEF, they want us to find the measure of angle F. So based on our letters and the picture, I know angle C is congruent to angle F. So C is congruent to F. Now, I don't know what the measure of angle C is or the measure of angle F, but because the two triangles are congruent, I can find it. I can take 36 and add my 96, and that will give me 132. Take 180 minus 132, and that would give me 8 and 4. So angle C is 48 degrees, which means that angle F is also 48 degrees. Now we have our first theorem of this section, and it is the third angles theorem. This is one theorem that you can use to prove angles are congruent in a triangle, but not necessarily two triangles are congruent. The theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent, which makes sense because all three angles have to add up to 180. Now again, this is a theorem we can use to prove angles are congruent, but we cannot use it to prove that triangles are congruent. All right, so we are going to use our third angles theorem to find the value of x. And here, I know that angle H and angle S are congruent because they're both marked with two arc marks. So I'm going to put my 92 degrees in there. And I also know that angle J is congruent to angle R because they have one arc mark, so that would be 53 degrees. And they want us to find x. So now, using my congruent triangles from this triangle, over here, I have all three triangles or angles. So I'm going to do 53 plus 92 plus 10x plus 5 equals 180 degrees. And then combine like terms. So I know that we will have, if I add them together, I will have 150. So we have 150 plus 10x equals 180. Subtract our 150. And we get 10x equals 30. Divide by 10. So x is going to equal 3. And that would be the value of x. All right, so the last thing we're going to do here is we are going to do a proof to prove that these two triangles are congruent. And right now, we don't know any ways to prove triangles are congruent except for showing that all three sides are congruent and all three angles are congruent. In the next section, we'll look at other ways to prove two triangles are congruent. But for now, we're going to start off with our statements. And our reasons. Okay, so first one, is going to be our given. So we know that LM is congruent to LO, and MN is congruent to ON. Okay. And I'm going to stop there. I'm going to not put the angles with it because I'm going to focus on the segments first. So I know that LM is congruent to LO, and it is marked, and MN and ON are congruent. Now, the third side of the triangle happens to be the shared side of the triangles, because the two triangles that we are proving congruent are this triangle right here, and then this triangle right here. But if you notice, they share this common segment. So this is where I talked about before using the reflexive property. It's hard, but it's super easy. So we are going to use our reflexive property and say that LN is congruent to ln, and that is going to be our reflexive property of congruence. So now I have all three sides congruent. I just need to do my angles. So my step 3 is going to be my other given, and I know that angle M is congruent to angle O, and angle MLN is congruent to angle OLN, because that is given. Now, they gave me two pairs of angles that are congruent in two triangles. So therefore, think about the theorem we just learned about. If I know that M and O are congruent and angle MLN and OLN, which are right here, are congruent, that means that I know that our other angles, angle MNL, let me put it on here so you can see it. So MNL, so this angle right here, is going to be congruent to angle ONL. And that is going to be through our third angles theorem. Now I've proven all sides are congruent and all angles are congruent. So that means that I can prove that angle LMN is congruent to triangle, not angle, but triangle, LON. And this would be just your definition of congruent triangles, because if all three sides are the same and all three angles are the same, they are congruent. So our reason would be definition of congruent triangles, and you can abbreviate there. And that is it for section 4.2.